Hi. So last weekend was FOSDEM, and it was as usual a very interesting experience, like every year. And we had like in the last 3 years we had like a GCC dev room, and it was also very exciting and very fun. And as part of that dev room, I had the privilege of doing like a small talk about introducing about the GNU Algol 68 project and the GNU Algol 68 working group and the GCC front end. And well, it was a little bit improvised, because originally I was gonna do like only a very short 10 minutes introduction to the whole thing, and I was a little bit afraid of that because that's really not that much time, especially for me, because as you see, I am rather verbose and I have a very hard time to not start babbling about whatever. But we were well. What happened is that one of the talks in the dev room got cancelled, which was bad because it was actually quite interesting one. And consequently, well, I had opportunity like well, I got like 15 more minutes. So in total, I got like 25 minutes, and of course, I used more than that with questions and everything. So at the end, I think that we managed to have like a useful talk and to reach more people about this project and what we do. So during this little talk in FOSDEM, I talked about two particular examples of programs written in Algol 68, which and in both cases they are like useful programs, or well, one of them is a useful program, the other one will be very soon. But they also, we use them as like test benches, test tools. We use them to test like the compiler, and not only the compiler, but also the different GNU extensions to the language that we are adding. How they are used, how do they feel, and of course, by writing Algol 68 code, which is very fun and very interesting and very satisfying, we get like, you know, what is the feeling for further extensions and what to not extend and so on. Anyway, I'm babbling again. So the two examples of the programs that they mentioned in the FOSDEM talk were, on one side, GodCC, which is a command line interface to compiler explorer instances like godpol.org, and the other one was a library, libterm68, that, as we shall see in a moment, is some sort of like of a mix between, what will I say, between terminfo and ncurses. Like, it's a little bit, maybe we will see. I mean, but it's that kind of library. It's basically a library that allows Algol 68 programs to use the terminal in more complex ways than just like writing stuff to it and like reading lines of text from it. And well, one of those programs is GodCC, which is a program. I mean, it's an executable, and the other one is libterm68, which is a library, and as such, it gets distributed as a shared object. So GodCC, we have talked about it in other occasions. I will only mention that we released the first version of it, like proper release tarball, like this week, and it's been already packaged in Gentoo, and Gentoo becomes the first distro ever, like to our knowledge, or to my knowledge, to distribute an Algol 68 program among Git packages. So congratulations for that, and thank you to Sam James for that, because it was him the one that packaged that. Anyway, so that's GodCC. Now, libterm68. So libterm68 is interesting for two reasons. One of the reasons is that it does like cool things on the terminal, and I needed that for some stuff that you want to do. But it's also interesting because it is the first time that I get to actually use the new module system that we implemented in the compiler. And also this module system, even though it was designed long ago by Charles Lindsay, which, you know, among the work that was made like in the maintenance phase of the Algol 68 program, we are talking about back in the 70s, it was never implemented until now. Now it's implemented in GCC. And so this is the first time that I was saying that we are actually using the module system in order to produce like a shared object, a library that it's well integrated in the system. And this is very important. I also mentioned this in the FOSDEM talk, but I think it's worth it to repeat it again. We don't want to be a ghetto language. What do I mean with ghetto language? Like programming languages that don't actually do a big effort to integrate in the system. And as a result, they have their own mechanisms for like distributing themselves, for like linking, and you know, that sort of thing. So our goal is to be well integrated in the system and to not require any language-specific toolchain other than the compiler itself in order to build, in order to distribute, in order to link, in order to, I don't know, create like wrappers or anything like that. So no cargos, no CNAT pins, nothing like that. Just GCC, like the compiler, the normal regular linker, the normal regular assembler, and the normal regular everything. The same for the build system. And so for us, that this is an important goal, and we work hard for actually keeping this like this. So libterm68 was a good way of actually seeing if that was a possible thing to do. And also it was a very good test suite or test bench for the FFI support that landed very recently in the compiler in GCC. Only yesterday I was fixing some bugs for it. So yeah, so this is libterm68. So let's take a look at it very quickly, and then after that I'm gonna show you, and that's the clickbait of this video, of the title, I'm gonna show you a small demo program which is there in demos, which is like a demonstration of the capabilities of this library. And this little demo is a little game, it's a little action game, and we shall see that it's not, I mean, it's actually even entertaining to play, and it showcases very well what you can do with this library. Anyway, let's take a look first to the library. So the library itself, first, so this is like the main directory of the source tree, and then again, this is a very normal, typical AutoTools little and simple project. You have makefile.am for automake, you have configure.ac for autoconf in the top level. The configure.ac, you have, well, the typical AC init macro where you define like the name of the project, the contact address, contact info, and so on. Other macros like libtool, we have to initialize libtool because this is a library. So of course we are going to use libtool to build the shared objects, the shared libraries, and the archives and everything. Not because this is written in Algol 68, it means that we cannot use libtool. So and that's the point of being well integrated in the system. If we integrate properly, we of course can use libtool because our object files are regular ones, our shared objects are regular ones, and so on. So note how we are using this acproc68, which is a macro provided by autoconf to search for some capable Algol 68 compiler, that means GCC basically. The Algol 68 support in autoconf is going to be released like maybe next week, maybe in a couple of weeks, in what will be autoconf 2.73, which is now in alpha version. It's in beta testing or alpha version or alpha testing, whatever you want to call it, but it will be released soon. And then you see here that in this project we also need a C compiler. And why do we need a C compiler? Well, because there is a tiny bit of C in libterm68, and that on one side that we will see now, and in the demo, which is this little game that I was talking about before, we are also making use of some system services, like system functions, which are those functions here, by using the FFI, and we are gonna see how that works as well. And then the rest of the files is the typical thing. Okay, in configure. The makefile.am, is just subdirs. I mean, it's very small. So let's take a look at the source code. What do we have here in the source code of the library? We have a bunch of Algol 68 source files, as expected, and we have one C file here. So when it comes to the makefile.am, this is also very simple and I would say quite well integrated. And even if you know nothing about Algol 68, what you see here, you should be able to infer what everything is for, because it's very, it's the same as with any other language. So basically you have first like this AM A68 flags. So A68 flags is like C flags or CPP flags or Go flags or GDC flags or whatever, which are basically like the flags passed when compiling Algol 68 files in all files, because this is the automake underscore version of it, the global one in the file. So every Algol 68 file compiled in this file is gonna be passed those flags, and then we are passing that we don't want a strict bare Algol 68, but we want the GNU extensions as well. The check nil, this means that GCC generates code to check for the referencing nil values at runtime. This is a security feature. And this modules map file, this is for actually, well, I may explain what is this afterwards, but maybe not. We will see how this video goes. Then here we define some library primaries, which are shared, are lib2 libraries, this libterm68.la, and then we define the source files. And then the source files for this primary are all the source files we have C, which most of them are written in Algol 68, and there is one which is written in C. And as you can see here, you can actually mix them. It doesn't matter. Automake knows what to do with any of those sources and how to combine them, because each of those source files, the Algol 68 ones and also the C one, is going to be built into an object file each, and those object files are going to be combined using the normal regular linker to get in this case on one side a static library and on the other side a shared object, not an executable, because it's a lib2 primary. Now you see here this dependencies section here that is actually empty. Okay, in the case of godcc, let me show you. Well, it's a very similar makefile, but only it's for a program instead of for a lib2 library, for a library. So you see the primary here is a program. It is not the highlight. Yeah, the primary here is a program. Now, in the case of godcc, we actually, I actually took the effort to list all the dependencies introduced by the modules that we will see in a minute. Well, as you see the note here, in the future, this will be generated by the compiler itself, instead of us to have to hard code the dependency rules there. And in fact, that's something that we will do probably sooner than later, because this is very annoying. It's a real pain in the arse, this thing of the dependencies. You may be wondering, so what's the problem here? Why Automake doesn't support like dependencies between modules? Is that not like a very common thing? And the answer here is like yes and no. So yes, obviously Algol 68 is not the only problem that uses modules as such, as an alternative for just like header files like CDAS and so on. It's not. It's not. Other programming languages use similar models, like the Fortran. Fortran uses the Fortran modules. They work in a similar way in this sense. And the Go packages as well, I think they are called Go packages, not Go modules. I'm not sure about that, but okay, it's the same, doesn't matter. And other programming languages. So yeah, in a way it's common, but it's not supported in Automake. And why they are not supported in Automake? Because the only support in Automake for like automatic dependency tracking is oriented to C. And in languages like C, it's always an optimization, but it's not absolutely required. And the automatic dependency tracking in Automake for C, when it is enabled, what it causes is that if you change one source file that makes a change in an object file, other stuff only gets rebuilt if it's actually necessary for it to be rebuilt. And in order to do that, Automake asks the compiler, using that -mf command line, so the compiler generates a make-like, using a make-like syntax, or actually maybe they are like pure, like actual makefile rules, I'm not sure about that, containing the actual dependencies that only the compiler can determine, or otherwise you will need to parse the C files and figure it out by yourself, because you have to understand part of the programs, of the C programs, in order to do so. Yeah, but so Automake supports this automatic dependency tracking only like the C style ones. And why cannot that be used for Fortran or for Algol 68 or for Go? The reason is that, as I have mentioned already, in the case of C, it's just an optimization, because since C relies on header files, you can always compile a C compilation unit by itself, always, because every time that you use something that is like defined in a different compilation unit, you need a declaration for it, and this declaration, it comes in a header file. So if the compilation unit compiles at all, and it doesn't have like parse errors or compile time errors, it can always be compiled in isolation, and the resulting object, it will always work, it will be always valid, it will never have to be recompiled afterwards. So that's one nice thing on how C works. On the other side, you have Fortran, you have Algol 68, you have Go. In those programming languages, they don't use header files. So when you compile a program, a compilation unit like foo.a68 that actually relies on facilities which are in a different compilation unit like bar.a68, you cannot compile foo for the first time unless bar is already compiled. So basically, in those programming languages, the automatic dependency tracking is not optional, and it has to be performed before you actually start building, you start compiling the first like compilation pass of the the compilation units. And Automate does not support that, and this is something that we want to add. Hopefully this is something that once we have it in place, even though we want it for Algol 68, it will be good for the rest of the programming languages as well that need this feature. Anyhow, so well, as I was saying, sorry about my babbling, but this is terrible. In the case of the program of GoCC, the dependencies are written here by hand. In the case of libterm68, not a chance, because I'm not gonna do it. is super complicated, because when libtool is not in the mix, is very simple. From a C file you get a .o file, end of the story. When libtool is involved in the build, for each C file or A68 file, it creates one object file with position independent code, and it names it like with some sort of prefix or whatever. Those are intended to go eventually to the shared object that requires position independent code. But it also builds the source again into an object that doesn't necessarily have to be position independent code, and that is the version of the object that is intended to go to the archive, to the static library. So, and then it uses like prefixes and stuff, and it's a royal mess. And that's one of the nice things of Automake, and you know that it isolates yourself from this libtool stuff, which is quite nice to have. But so anyway, that has the bad side effect that it's very complicated. I'm not even gonna do that right. So what this means in practice? That when you build libterm68, you have to do it with no parallelism, with no -j. I'm sorry about that, but that's how it goes, at least for now. So this was the build system. What about the source of the library itself? Okay, so let's start with libterm.a68. This conforms, this is what we will say is like the top level module, if that has some sense, makes any sense, of the library. So basically, you know that an Algol 68 compilation unit, so an Algol 68 source file, each Algol 68 source file, we call them packets. It's a packet, and can be of two types. It can be either a module definition, a definition module, which is like this file here, in which it actually defines a module, or it can be what we call a particular program, which would be like a program, like the main program, like a main program. And in this case, this is a module definition packet, and this module definition packet is defining a module called term68. One note about the name of the module. This module is called term68, right? So this means that when programs or other libraries want to access this module, they are going to do an access term68. And this means that the compiler is going to look for this module in libterm68.so. And that's basically what we want. And that way we don't have to use like module maps, like was this module mapping file I mentioned before. So that's why when you make a module in a program, in some code that is intended to be like a shared object, keep in mind that it's always the best to name it in a way that you will be distributing this module in a file called lib_whatever.so. So term68 is nice. So this module, it accesses other modules, and it publicized the contents of some other modules. That's why, so it accesses this t68 config, which is a module that it uses like internally. And it does not publicize any of those definitions. So the definitions publicized by t68 config are available in the module here, in the prelude and postlude of this module, but they are not available on the programs actually accessing this module. In contrast, the t68 error term and unichars here, this module is publicizing the definitions of those modules. And this is a nice feature because you don't have to repeat everything, so to say, right? And also, this module is publicizing an extra and unique and only one additional identifier, which is term version, which contains the version of the library. And I believe this t68 version actually comes from this t68 config. All right, and it does nothing else. So let's take a look to the main file in this library, which is t68 term. This is t68 term module, which is here. And we see that this is another module definition packet. This time is defining a module called T68 term. And this, again, this module is accessing some other modules. And one of those modules is publicizing this definition to the caller. And this publicizing is like recursive. Like T68 term is publicizing the definitions of T68 post. We know to T68 term, and again T68 term is well, you know, I mean it's recursive. So what is this package, this module doing? So this module is publicizing a mode, which is a type in Algol 68 jargon, which is a struct, which is a term, and this represents like a terminal, like the terminal, like the screen and the keyboard. And when we create one, basically we characterize the terminal with an input file descriptor and an output file descriptor. And those are like literal POSIX Unix file descriptors. So when we open a terminal, like with this call, you see that it yields a reference, a name of a terminal, a reference to terminal. We pass an input file descriptor and an output file descriptor. And then in this call, and also we pass how many columns it has and how many rows it has. And this creates terminal and returns it and yields it, but also it creates something called a viewport or a terminal view, which gets associated with this terminal. And this one, it gets like written in this actual parameter viewport, which is passed a reference to a terminal view, to a term port. So since it is a reference, it can refer to a value, and the term open sets the value this refers to. This is a nice idiom, a nice idiom in Algol 68 of using the references to return more than one value from a routine, in this case a procedure. So this viewport thing, we will see when in the game, you know, when we use this, but very quickly, basically you have the terminal, which is the input and the output, and then you have a tree of viewports, a tree of terminal views, which are like views into the terminal, like windows, like sub windows or windows, and you can have sub windows of those windows, because you can organize those viewports like in a tree. And then here we have, which is very common as well in Algol 68 modules, some of the routines are publicized, which is the conform the public interface, but many others are not. And those many others that are not usually are like utility procedures, which are used by the ones that you publicize. We are not going to stop here in those. Here we have the mode or the type for the viewport, for the terminal view. We see that they have an app. The app of a terminal, of a viewport, can be either a terminal, if it is the first one, or another terminal view, if it's not the first one, right? I mean, if it's down in the tree. And each view, basically it has a dimension, how big it is, and where it starts. And the coordinates on where it starts are in the reference system of the parent viewport or of the terminal, of the big one, right? The main one. Sorry, I got a message. You know, I have no idea about how to edit videos, so that's why with me you get what you get. I have no idea about those things. Sorry about this. Anyway, so this was like a viewport. Yeah. So we publicize a routine, a procedure here for creating a viewport. That you return it, you yield it. You specify the origin and the dimensions, and all that you give the viewport that is the parent of this one, right? And then here you have like a plethora of useful terminal operations, which are operations not on viewports, but on terminals. On terminal itself, like the save the state, restore the state. The state is like all the different flags and features of the terminal, like the echo is enabled, the echo is disabled, and so on. What is displayed, what is not displayed. This usually you do when you start your application, and when you exit your application, you have to, when you start, you save the status of the terminal. When you exit, you restore the status of the terminal. And so too many often people are not careful enough, so then the program crashes, and then you have a fucked up terminal, and then you have to do reset in the terminal. So if you call restore state before you exit, even if it's in an error state, that will not happen. You can change the cursor visibility, like the cursor is visible or not visible. You can change if the echo is enabled or not, meaning that when you press a key and even before that gets processed, it is shown in the terminal, so you can disable that. Whether the terminal is in raw mode or cooked mode, very quickly explained. Terminals, yes, they have like an input device, like a keyboard, and an output device, like a screen, and you type and then you see in the terminal and so on. Yeah, that's all very good, but the terminals by default, they work in a mode which is called cooked mode or non-raw mode. And in the cooked mode, certain things are interpreted by the terminal itself instead of like taken literally, so to say. And this is called line discipline, and it's not a trivial thing. It's actually interesting. It's quite fascinating how complicated that can get. But well, certain things are interpreted. Like for example, certain control characters like Control C or keystrokes, they get interpreted as, okay, I have to send a signal to this program, a signal to this program. Or if you type like foo 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 in the keyboard until you press the enter, those foo 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 foo, everything that you write in that line is not sent to the application. It is actually buffered by the terminal, and it's only when you push enter that the data, the information actually reaches the application, which is connected to the terminal. And the terminal, very often, also provides like edition capabilities in that line. So you have like a small line editor implemented by the terminal. So this is all in cooked mode. When you switch the terminal to raw mode, all of this goes away. The line discipline goes away. The interpretation of the special characters, control sequences, and so on, it also goes away, and you have the terminal in raw mode, which is most useful when you are implementing like TUIs or games or stuff like that. The set time set min, we will see an example of using it. You can change the graphic rendition of the terminal. We will see examples too, like changing the background color of the foreground color of new stuff that you are going to write there to clear the terminal, like wipe out all the contents. And then you have operation of viewports. So as you can see here, the operation of viewports, there are like two main things. On one side, everything that is related with positions and movement is done on the viewport, not on the underlying terminal. Why? Because it is the viewports that actually have an origin and a size. And each viewport has its own origin and its own current position. Its own cursor, if you want to call it like that. And so depending on which viewport you write, which port you write or you operate with, it has its own current position. This is very useful. And its own local space of coordinates also for its contents. And this is why initially when you create a terminal using this library, you always create a viewport along with it, which is the viewport covering the totality of the terminal. So those are these services here, those procedures like the size, like go to the left, or turn right, turn up, turn down, like move up X positions, move right N positions, and so on. Always on 10 views. on viewports. And then you have the procedure that you use to write stuff into the terminal, or I should say to write stuff into the viewport, right? Because again, you can only write in the terminal through a viewport. And so you specify a viewport, and then you pass a multiple of united values, which could be a character, a string, or a procedure. This procedure is not used for now, but it will be. And this uses like the typical traditional trick in Algol 68 that basically is that you can pass a row display or a multiple, an array of any combination of characters, strings, or these procedures, or only chars, or only strings, you know, because it's a union. But since this is a multiple, yes, you can pass like open parentheses A, B, C, but you can just pass only one element, because in a strong context, which is like the actual parameter of a procedure is a strong context, which is a context, syntactic context in which it is known at compile time which one is the required mode or type there. Rowing is allowing, which is one of the 6 coercions, and this means that if you pass a single character, it will be rowed into a multiple of unions of characters, because it will be united and it will be rowed. 2 coercions, which is, you know, is the typical Algol 68 syntactic magic in action. So this provides a very nice and comfortable interface. Now here is something interesting too. Look at this access here. You have seen, and probably maybe you will be used to see it in the future, that usually you see access clauses like at the beginning of the definition of a module, like in this case, or in a particular program, before the particular program, for the begin end, the close clause to the particular program, you have an access which is, okay, I have this main program here that accesses those modules. But in reality, you can use an access before any enclosed clause, like before this begin end, or before a for, or before an if, and in each case, the range where the access actually applies is that one. So we have here an access transpose, because somewhere in here, probably we are using some transpose routine, yeah, like charring strings in a string, which is part of the transpose module, the standard prelude, the standard library. Sure, you could have put here the access, because the charring strings is only used in here, but okay, we opt to put there. Okay, so this is the output routine, and okay, we have those procedures for use to the interface, but this is not finished yet. Another nice thing about Algol 68 is the skip. The skip is fantastic, really. It is, I don't know, when you start using this programming language, how can you live without a skip in other programming languages? So basically a skip in Algol 68, which can also be written as this, which is shorter. A skip is a special, it's a unit in Algol 68 that basically, strictly speaking, in a strict Algol 68, a skip yields or evaluates, a skip yields to some value of the required mode, of the required type. Which value? You don't know. It's not defined in a standard Algol 68, and you don't care, actually. In GNU Algol 68, it's actually well defined, which are the sum value of whatever mode that you get with a skip. For example, if the skip is an integer skip, you get 0. If the skip is a real skip, you get 0.0. If the skip is a string, you get an empty string. If the skip is a struct of blah blah, and so on. If a skip is a multiple, you get an empty multiple, right? And so on. So in Algol 68, it is well defined what you get if a skip. In a strict standard Algol 68, you should not rely on that. But in any case, the utility of a skip is precisely that you don't give a shit about what the value is, because all you care is that you must have a value of that mode there, and it's super useful in cases. For example, I started writing this t-backtrace procedure, and then I said, okay, I'll do this later. I just put a skip there, and no matter how complicated, no matter how intricate, no matter how remote the syntactic position is in our current program, as long as it is a strong context, which again is what any part of a program in which it is possible to determine what is the desired mode statically, maybe not for you as a person because it's too complicated, but certainly for the compiler, you can put a skip there. So fear not, in a formula, as an operand of an operator in a formula, the body of a procedure, or well, in this case it is the unit in a routine text, anywhere, put a skip in it, and you put a skip in it, it will compile. Now, of course, you will get a value that you are not, that is some value, but it's very, very nice, especially when you do this sort of like top-down methodology, or okay, I will write this later. Just put a skip there, put some sponge or xxx comment, and you will be back to it. It's very nice. Anyway, so yeah, this is working program, and then well, we have here some definitions of colors. Right. What else is interesting? Okay, we have seen that there are a lot of like positions. For example, when you say, okay, this is a private procedure. Let's see some public one that uses positions. Well, actually, not many. No, not many. Okay, well, so okay, so for example, well, those positions are basically like rows and columns, and if we go, they are implemented in the module T68 pos, which is this one. Again, this source file contains yet another definition module. In this case, this one, okay, yeah, we reached the bottom. This one does not access any other module, and this basically defines like a module called pos for position, a mode called pos, and values of this mode are basically they have an integer c and an integer r. C is for column, r is for row, and well, it's like this coordinate system, like Cartesian space, like with columns and rows, and we have something called no pos here, which is a constant. This is an identity declaration, which is publicized, which is 0, 0. Note that both columns and rows start with 1. So 0, 0 it doesn't refer to any character in any viewport. So it's useful for like denoting like a no position or an error position. And then we have here, well, to add positions, to subtract position, to equal, not equal, bigger than, and so on. So what is interesting comment? Some comments about this code. Okay, first, you see how compact this is. It's very compact. You see in Algol 68, the more Algol 68 you see, you will see more and more. At least if you read Algol 68 that I write, is that the contracted forms are used very much. What is the contracted forms? Okay, so this is a publicized operator plus that is defined by this text routine. So this is the definition of one operator. So in principle, you could write this like this, and you can. But it's better, at least for my taste and my economy, to use the contracted form, which is that we will see later also in the other programs. Instead of saying int foo semicolon int bar semicolon, you just do int foo comma bar. Or in the same way, this, for example, in this mode, it can also be written like this, but it's better to write it like this, because you don't need to reiterate it. So those contracted forms are very much used in Algol 68. Unlike in C, for example, where they are basically an anomaly, they are syntactically dubious. I mean, no, they are sound, but for the user they are dubious. Like, you never know when it is allowed, when it is not allowed, because the syntax of C is not orthogonal. C is not an orthogonal language, not a very orthogonal language. And the contractions in C, I will say perhaps that is one of the so many examples where they try to get some concept from Algol 68 and they lack the proper ground where to evolve, to develop it properly. And anyway, in Algol 68, which is orthogonal and has an extremely well designed syntax made with a lot of love and by very serious people, you can use contracted forms like almost everywhere, and they are a delight to use. You can see, and also they are very readable. Yes, I know that my fonts, I like square fonts, and I don't like a lot of spacing between lines, and I had to change recently from yellow and blue because I'm getting old and my eyes get tired, so I need more contrast. And yeah, my tastes suck, but forget about my color choices, forget about my life choices, and focus on the syntax. If you put it with your font and in your color theme, it will look good for you, to you. Anyway, so the compactness. Here we have 1, 2, 1, 2. So this is 1, 2, 3, 4, 5, 6, 7, 7 operators. 7 operators defining that many lines, in several lines, and one mode, one type definition, and one constant definition. And you see it's very compact. Something else that you may be wondering about is, what is this thing? What is this apostrophe thing here? Okay. So in Algol 68 you have selection of structural values, like you have in C, you have in so many other languages. Because obviously, if you have a value of this mode, which is a struct that has 2 fields, you need a way to refer to those fields individually. So in C, if you have a pos A, which is a pos, and you want to access the field C, you will write a.c. In Algol 68, in the standard classic Algol 68, you write C of A, which is also allowed in GNU Algol 68, obviously. So you see that it goes the other way around. So instead of going from left to right, like from A get the field C, a.c, it goes from right to left, which is C of A. And this is something that certainly is not very common in programming languages today, and it may feel a little bit weird at first, but when you get used to it, it actually makes, in a sense, make at least as much sense as the alternative. I mean, it takes a little while to train your mind about this, but it actually makes sort of sense. And in fact, in C, at least for example, in the frontend, the Algol 68 frontend of GCC, we use macros in order that we can use the same sort of logic in C. So we have macro next and previous, and so we have next of previous of next blah instead of p dot previous dot next dot previous, whatever it is. Well, anyway, so this will be like in classic Algol 68 you will write this. So in this case, it is the addition. So it's a Cartesian addition. Now it was recognized very early in the history of Algol 68, that there is a problem with the notation, and the problem is not that it is from right to left. No, the problem is that it's very long, it's very big. I mean, this off construct, it takes, with the bold word off, it takes at least 4 characters, and that's quite a lot. That's quite a lot. And when you have like expressions like this one with a lot of offs, your expressions gets huge. So this classical notation is useful and it's nice, especially when you have one selection with several offs one after the other, not separated like with operators like here. But back in the day, Hansen, who was the main person that made the Algol 68 standard hardware representation, they already thought about this problem and they wanted to use one character representation, alternative representation of this bold word representation. Like many other constructs in Algol 68, you have a bold word representation and you have a shorter symbolic representation. And like for the conditional statements and so on, and also for the operators. So they wanted to use the apostrophe precisely. Why they wanted to use the apostrophe? Because in words of Hansen, it is a worthy character, meaning that it's in the list of the characters which are worthy, can appear in Algol 68 program. In GCC, in GNU Algol 68, we have a very well defined set of worthy characters which are defined in the document, in the manual. But still, even being a worthy character, it's not used anywhere out of string denotations. Because in Algol 68, the quote, because we have to do it because that's what mandates the standard hardware representation, is the character used to escapes in string denotations, in string literals. So instead of backslash, like C dash, we used singular. But out of string and character denotations, the apostrophe is not used at all for anything else. And they recognized this back in the day, but then they had a problem. And the problem was that back then, quote stropping was still a huge thing. And obviously, if you use quote stropping, it will be quite complicated to use quote, for field selection. So they could not do it. They could not use it. So alternatively, Hansen suggested a super cute thing, which was to use this operator, this notation, dot slash, and at least you could save two characters, because unlike the bold word, you in reserve, in stropping using reserve words, you can actually use two characters. And the reason for using dot slash, it was because it sort of looks like a calligraphy off. You see, it's like off. Okay, well, this is a camera. I mean, like off. I find it's very cute, and but actually they never use this. And as far as I know, no Algol 68 compiler or dialect compiler actually implemented anything else than the normal bold word off. But in GNU Algol 68, we can use single strop. We can use single strop. We can use apostrophe. Why not? I mean, quote stropping is not something that is used anymore. And in any case, in GNU Algol 68, in GCC, we don't support quote stropping. We also support upper stropping and our modern super stropping. And the other modern Algol 68 implementation, which is Marcel's Genie, Algol 68 Genie, the interpreter, it also supports only upper stropping, and I think point stropping, because you have to support point stropping, also point stropping, but not quote stropping. So this is okay. We can use the single apostrophe. So as you can see, I use the short form, the quote, in situations like this where using offs will be less readable. But as you shall see as well, I use the off notation in other situations where it is perfectly readable, or even more clear than the apostrophe. That's a nice thing of having like two different ways of doing it, two different representations. And by the way, this is 100% conformant with the revised report and the standard hardware representation. Anyhow, so this is the position Yeah, what else I can show you about the libterm? Well, the ANSI support. What is the ANSI support? So basically, the way you get terminals to change their behavior, you can do it in two different ways. You can do it via some C calls, like which are eventually they are like IOCTLs, but like library functions. And those library functions, well, you set like certain like capabilities or whatever. And those library functions are specified by POSIX or not, or they are provided by your operating system, and they may be not standard. But there is a standard for terminals in which you can command the terminal and to some extent even get information from the terminal by writing certain control characters or control sequences of control characters to the terminal. And this is very nice because it doesn't matter what kind of terminal you are using, if it is the Linux console or if it is an Xterm or a terminal emulator connected to a PTI or whatever. It doesn't matter if the terminal is ANSI, implements ANSI, is compatible with ANSI. The same control characters will do the same in any terminal. And this module, this is once again, this is another Algol 68 source file that is a packet that contains a module definition called in this case T68 ANSI. And well, you have here like this a proc ANSI control that you provide a string which is a sequence of control, and some of them get arguments, so you get it in a multiple array of arguments. And we have here a set of standard ANSI control sequences in which you can actually introduce like those arguments. And as you can see here, you can clear the terminal, you can move the cursor to the home, which I suppose is the position 1-1, I don't know. They save the state, they restore the state, erase to the beginning of the line, so from the cursors to the beginning of the line, erase to the end of the line. This is useful for erasing, you know, like move here, move down, move this, move that. So this is like the ANSI interface. I mentioned at the beginning of the video that this library is like a mix between libterminfo and ncurses. So this will be like the terminfo part of it. The terminfo of course is like the standard Unix or GNU in this case database for different sort of terminals which are slightly different and do things. Some things are more efficient to do in some way or another. We got it much simpler. You know, it's just this little ANSI package module. And then we have this is a funny one. This is a module, another definition module called ncurses, where I have basically the definition of many constants which contain some, well, many, you will say, some drawing characters, which are all of them are standard Unicode. All of them are standard Unicode. And as you will see, so we have here publicized char. This is another example of contracted forms. You don't have to do pubchar, 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 pubchar. And then, for example, white bullet. So the white bullet is this. What is this? Okay, this is a character denotation. This is not a string denotation. You know, in Algol 68, the character denotation also uses double quotes, the same that the string denotations, but they contain only one character. And the beautiful thing is that you can put, you may say, oh, well, this is very confusing. But it's not, because most of the time you don't care about the difference between a character denotation and a string denotation, because a string is a multiple and a character denotation can be rowed, be a conversion to a string automatically. So if you put a character denotation in any syntactic context in which a string is required, it will be converted automatically for you to a string. So, nah, it's okay. And here it is the escape, as we were talking before about single quote. This is, you can use single quote, open parentheses, and then you can have a list of Unicode code points, and then the string will be composed of those. In this case, this is a character denotation, so you only have one code point. And the code point is the Unicode code point of whatever drawing character. Those are comments. I am recording this in the Linux console, because I use the Linux console I live in the Linux console. But I make sure that the font I'm using actually has all the drawing characters that I need. And indeed, you may be wondering, how did you write this? Because why nobody is using the Unicode drawing characters to draw stuff, like in text files? Because as a matter of fact, almost every Unicode font actually supports the drawing characters. It's not that we have in our systems like fonts that that lack glyphs, like out of the BMP, even though those are in the BMP actually. No, that's not the case. I mean, our systems, they have like TrueType fonts, like with at least the BMP, for sure, and drawing characters for sure. We have super good fonts. Why no one is using them for like drawing stuff? You see shitty ASCII art, 7-bit ASCII art everywhere, which I like, but I mean, it could be better. Well, I think the reason is because it is a pain in the ass to actually type those characters. So for that, what I did was to write an Emacs mode that I have not published yet, but I may at some point. I use it for myself, in which you see I have like this, I call it a golf ball keyboard. So when this is activated, then I have, like I can, I don't know, let's do something silly, like this. Let's connect this like this and like this. Let's make a key, for example, a key, right? And then when you are done, you just go back to the normal mode. But this is text, which means that you can copy it, and also you can get diffs. This is a diff, Very nice. Well, so I hope that, I don't know. Well, I use it all the time. That's the thing. Anyway, and here we have all those characters. And note that this module is publicizing the name of those characters by name, and the term is publicizing. The libterm, the top level one, is actually accessing the unit charts and publicizing its content. So this means that when the program we shall see we access the term68 module, we will have access to those characters. And that's basically it when it comes to libterm. That's basically it, and this is getting too long already. So anyway, so this is the library. So let's compile it. Disclaimer, the compiler is slow because the GCC I'm using, it was built with enable checking, which is a development option that makes that everything is checked at runtime. And also I built it with minus G3 minus 0. So this is a not optimized GCC, okay? And it's good for debugging the compiler, but it's super slow. Anyway, okay, so now it's built. So what did this build? Well, the library lives here. It is this shared object, basically, libterm68.so.000 and with the link here. And the object dump, and basically all the export information from the module is in the .a68 export section in the shared object. So there is no header file. We do this like Go, because I got this model from Go, and they are nice. They have a nice module system, so I copied it basically. in that regard. Like this strategy of putting it in the contents are completely different. All right, now let's go to the demo, to this little game I was talking about. So the demo is in directory demos, and okay, forget about this rainbow. It is the Snake68. Yeah, a snake game. Well, I think this one is slightly more interesting than the usual ones. So let's take a look. So this is another source file, but the source file is not a definition module packet. Its packet contains a particular program, finally. So this is a main program, right? This is like the int, the main function in C or whatever. And this main program, we have an access term68. So when we compile this program, oops, so this program when it compiles, well, here in the automake, we have like the bin programs. It's executable. The sources is the A68, and we are adding here an LD-add for the libterm68. This is a libtool library, but at the end, this means that it will have a -l term68 -l term68 when you link. And the compiler itself, when it builds this particular program, is gonna find the export section in the shared object via this -i option here. So this is the same -i option that you use in GCC when you build C to find header files to include as headers. But in this case, it looks for DSOs, object files, and so on to get the export data. Anyhow, this compiles into an executable, and actually it compiled already. Snake. Yeah, here it is. You see? Okay, so let's take a look. So this is a snake game. Okay, I'm gonna show it to you first. libterm68. Alright, build. And this was in demos, so it should be here. Okay, so as you can see, this is the first level. Okay, the second level is a little bit faster. Oh, the frames are off. It's more difficult because you cannot say the frames. Okay. Oh, now there are impostors. There are dummy targets. You see, that was a dummy target. This one was not a real one. Uh-oh. I think I'm fucking this up very badly already. Yeah, I'm not. Okay, I died. So let's see if I do better, so I can show you some more levels. Nah, I'm so bad, you know, like playing games. I'm very bad at playing games. Okay, so the no border one. Aha. Okay, let's do it. I will not reach. I wanted to show you the wizard because I'm very happy with the wizard. Yes, there is a wizard mark in one of the levels in the fourth. No, in the. Okay, last time. If it doesn't work, I'm sorry, you will not see the wizard. Or maybe we can hack the program so you can see the wizard, but. Or you will have to. You will have to play it yourself. Uh-oh. Oh. I lose. Okay, the very last time, I promise. This is because I'm nervous. I promise that I can get. It has 9 levels, the game, and I can get to level 8 sometimes. But I've never been able to actually pass the level 8. I'm nervous because of I have public. Well, okay. Let's hope it is one. Okay, I'm sorry, you don't see the wizard because I suck. Anyway, so that's the game. As you can see, it's an action game, and yeah, I mean, you have different areas and whatever. Good. So how does this work? Okay, so we have the particular program. So this means that when the Algol program starts executing, it starts here. So the first thing that we find here is the definition of some constants, or those are identity declarations, but they are like interesting constants. Well, in Algol, a constant can be of any mode, and the mode can be a procedure mode or an operator mode. Why not? Or an array of procedures or whatever. It's orthogonal, so it can be anything. In this case, mRandom is a constant, which is a procedure that yields, returns a long int. And usually, you will have here a procedure, a routine text like this one, like a lambda with some Algol 68 code. But here you have an SC whatever. What is this? Okay, this is what is known as formal holes. Why holes? Because it's basically like a nest or a hole where you have to plug something to make it complete. And why formal? Because the formal is like a formal parameter when you pass an argument to a routine or in an identity declaration. It's basically in the formal hole you have to put an actual hole. You have to put it with something actual. Right? And this is the mechanism that Algol 68 uses for actually invoking stuff written, interacting with the stuff written in other languages or in the system. In this case, C is for the C programming language, and random is the name of a symbol. So we need to access the random C function, so to say, or system function. We do it like this way. Now, the compiler, it takes the work to actually insert, if necessary, whatever conversion code to make sure that from the Algol mode, like a procedure that gets an integer and return a value, for example, here, to do the right thing, always do the right thing when you call srandom, for example, the csrandom, the system srandom from the Algol 68 msrandom in this case. Other than this, you don't have to do anything else. So the FFI, or accessing C functions or system functions, is as simple as this. And this is why it is the reason why in the configure script we had this macro here, AC check funcs. Okay, make sure that random exists, srandom exists, and uslib exists in the system when you build libterm68. Why? Because this demo actually requires them to exist. But you don't need a header file, you don't need anything else. So as simple as that. Okay, we have random, which is the standard POSIX random, the standard POSIX random, and the standard POSIX micro slip. Then we have a little procedure here to restore the terminal to a sane state. We have here, you remember, we mentioned before the term clear, terminable echo, we saw it in the library. Here we have a little procedure that given a viewport, you remember, which are like those windows, those holes through the ones we can operate on terminals. Just draw a frame, and it uses some of the characters from the unichars that we saw before. Like, well, it does like this, a loop. There is a loop, and with two loops, two inner loops there, right? Yeah, so interesting things here. Well, note that, for example, in this for loop, it's for row 2 term rows, the number of rows of this terminal. I don't put like from 1 because the from 1 is implicit. If you don't specify from a from value, it's always 1. So it's, but for example, here, no, here is for I from 2 to the term columns but -1. Okay? And this small little procedure. What else we have? Okay, so we have a procedure that gets a random procedure for a target. Target is like the enemies, like that you have to eat with the snake, which are those crosses. Okay, those crosses. So this given a minimum column, minimum row, and a maximum column, maximum row that define an area. Actually, those could be posts, right? But okay. Give me a random position inside there, and then here is calling mRandom. mRandom, remember, it takes no argument. So in Algol 68, to call a function, a procedure that takes no argument, you just write the name. You don't have to write open parentheses empty and nothing close parentheses. You have to shorten it. Why? Because it is a long int. Look, random gets you a long int. So we are shortening it into a... Oh, I got lost. Where is it? Yeah, here. Into an int. And then this percentage plus asterisk star, this is module. This is module because only percentage is natural division, like integer division. And this is integer module, this module. With the max c plus 1 minus min c plus min c, this is the usual stuff, and the same for the other coordinate. And note that what is this? This is a row display. This is like a denotation, even though it's not technically that. It's like a denotation of an array value, of a multiple value. So, and note that in Algol 68, here you can have any unit, and this is a unit. So you don't have to put begin, return this, or begin and this. You could, but you don't have to. Okay, it can be very compact. All right, here we have like a big, this is all very small. This is the procedure that it draws the current level, like the different characteristics of the level and the different windows, but we will come to this later. Displays a message in the message viewport. We will see this later. And then the game one, which this is like where the action happens, but it's not that long either. It's only this. And then here, and this is it. This is the end of the program. And then here is after all the definitions of those routines. Okay, the first thing we do is that we install a handler for errors. So we have seen that libterm68, well, actually we have not seen it. You see how it is pub t68 error, and in t68 error, basically what this publicize is a variable, because this is a variable. The mode of the variable is a procedure that gets strings and yields nothing. And the default implementation is just to put the message that it gets to the standard error and do nothing else and return. But here we are saying, okay, this is called if there is some error while you are using in some of the calls to the libterm68. So we are basically, this is a string notation, a string test, which is some sort of like a lambda, right? And we are assigning it to it. So basically we are saying that we restore the terminal and we put the message on a new line and we exit. POSIX exit is the exit, Unix exit call with an error message, with an error status. And since we are restoring the terminal, we are one of those nice programs that actually restore the terminal before exiting. Okay, even in case of errors. And then we initiate all the terminal and the different viewports. As we explained before, the viewports are like a tree. Actually, here in the README of the library, that is not, well, you have it. So this is, for example, 1, 2, 3, 4, 5 viewports, including the initial one that covers the full terminal, and they could be organized this way. This is one of the many ways that it could be. And for this game, for the Snake 68, we have this. So we have the overall, the initial viewport, which is VSCN for a scene. The viewport of the scene, which is not here because it's covered by those. And then we have one viewport for the level, which is, you remember when it was level blah. One viewport, one little window for the messages, like, oh, it's getting hot here, whatever, and the grid. And the grid is where the snake is like going around and the enemies are, the targets are. And then, well, first we create the terminal, like we saw with term open, and we specified std in, std out, which are the standard file descriptors. We say that we want 80 columns and 50 rows, and we specify the viewport for the scene. So this is the initial viewport that covers the entire terminal. Now, this is, you may think, okay, what's going on here? look, VSCN is used here, but it's defined there, it's declared below. What's going on here? Well, what is going on here is that Algol 68 allows you to use identifiers before they get declared, provided that they are declared in a range which is accessible, right? And this is another of the so satisfying and nice syntactic properties of this language, because you should put yourself in the position of a language with actual lexical scoping, like this one, where you actually have procedures. Inside the procedures you define other procedures and so on. Here inside the begin end, which is the particular program, we have procedures. It's super nice. For example, here, let me see, one of the so for example, this target post is using mrandom. Mrandom happens to be declared before, but if we move those declarations down, it works. In fact, it doesn't matter how you shuffle the declarations, it will still work, because the important is that the declaration should be there, but it doesn't matter if it is before or after, right? And here actually you can see one of the occasions. Okay, why is that practical? Well, first, because it is lexically scoped and you can actually move things around without the fear of breaking everything every time you move something. Like in C it happens. If you have big C programs with a lot of static functions and you don't have huge collections of forward declarations when you actually don't need them. I hate that. I hate when people do that. It's better to just have the minimum, absolutely minimum necessary set of forward declarations that you actually need. But the problem with that is that if you start moving things around, then at some point you will need another forward declaration, and then you will get a compile time error. And God forbids you if you start actually seriously shuffling things around and the file is big. Then you are in trouble. Well, anyway, in Algol 68 you don't have such problems. Also, it's naturally useful, obviously useful, when you have mutually recursive functions. Like if you have a procedure that calls another procedure that calls the first procedure, you don't need any sort of forward reference. Also, you don't need forward references. You don't need forward references for anything in this language. Anyway, and here you see one instance of this. So if this was C, you will say, okay, so term, imagine, gets a pointer to an VSCN. Okay, you have no choice. And then you have this, and then you have this. Oh well, yeah, I guess, but no. This is not C, this is also Algol 68. So here you can refer to this one, even though you are initializing it before it is declared. What's the problem? No problem, okay? So we create the terminal. When we open the terminal as a side effect, again, it creates an initial viewport that covers the full terminal. And then we create the rest of the viewports. And the three viewports, the parent viewport is the main viewport. Yeah, I sound like a stupid, but okay, yeah. So, so it is a tree with only two levels. Frequent in the terminal, 2 levels of viewports. And well, it took me a while to get this right, because the moment I start, with columns and rows, and I get all confused. But that's me. You are smarter than me, for sure. So yeah, it works. I mean, this is this the origins and the sizes, and they should be. And then once we have the viewports created and the terminal opened, then we save the state of the terminal. This state, the terminal right now has not changed. We have opened this terminal, but we have not changed anything. So this is as like this, normal, in the shell. Okay, and then we hide the cursor. Then we disable the echo, and we set the time and this min. What is this? The time is the timeout that when you read from the input of the terminal, like from the keyboard, that timeout until it actually gives up waiting for input, and the read function or the fread function actually returns with an end of file. and we are setting it to 0. Why? Because every time that you want to change, so there we will see that there is an active loop, it's a loop, and well, we will see. This sets the timeout to 0. And this mean is something similar that I am not sure what it is, but that's how it is. And then it sets some globals, and then again, you see they are declared here, because it makes sense to declare things at the same place where you are actually giving them meaningful values. And so here we said the first level is 0, which is no level. This seed is for the random number generator. Initially direction is right, sorry, for you is like this, right, which is where the snake is going. The current position, current column and current row is the initial position for the snake. So you will see is the column is the second, and the row is the number of rows. In the scene viewport, the general viewport, more or less as the same at the middle. Remember that the percentage sign is integer division, okay? So more or less like that. It goes from to the left at midway. And then while the level is not 10, because 9 is the last level that I could not beat, but I wrote the game yesterday, so I still have time. Then we iterate game, we call it game, like increasing the level. If we get out of here, it means that we have won the game. It means that the level is 10. It's after level 9. So then we set the forward color to green, a happy color, and then dialog is that in this viewport app we say you won. I have never seen this, well, only tested yet. And then this is a label, game over, which is a label, normal syntax for a label. We will see who is using this. And then we call term restore, which is the small procedure that we saw. And then we reach the end of the particular program, we end the program. Okay, let's take a look at the game procedure. So, so in the game, in this procedure, we get the level, which is okay. Play the level number 1. It starts with 1. So the first thing it does is that here this is a variable which is local to this procedure, visited, which is a multiple of booleans, which is a matrix. You see, it has two dimensions, two ranks, 2 dimensions. The first one is the number of rows in the grid. Remember, the grid was this one, this viewport here where the snake moves and everything. So basically we are creating a multiple, a matrix of booleans of the size of this grid, and it's allocated on the heap. This is, you know, the heap generator. If you don't put it here, nothing, it defaults to lock, and lock is on the stack, but we want this on the heap. And then it initializes all the entries to false. And then we have here a little auxiliary procedure, which is called setV, which is set visited, that it sets the visited of the current position. And you see, this is a global too. Where is the current position? Oh well, it's defined here below, right? So of the current position, for the entry for the row of the current position and the column of the current position, it sets this to true. This is a little small utility function procedure. You will see that in Algol 68, you basically define and use procedures like super often, because they are so convenient, they are easy to write, they are easy to short write, and so on. So then you draw the level, which is, we will see it, you display the current level in the viewport, you see, viewport level. Then you go to the 4 local coordinates of the little window and you print the level. Whole is like this from the transport, that's why there is an access transport here, is the standard transport. This is the A to I, basically, of Algol 68, the standard one, which is way more powerful than the C one. Well, the speed, here you determine which one is the position of the target that you have to hit with the snake. And you see here that the position is different depending if we are in the level 5. And this is the reason is that the level 5, which is the one I could not show you because I suck playing my own game, is the level of the wizard. No, yes, it's the level of the wizard. And the wizard does something graphical that requires some certain amount of space, and that's why it needs more margins, so to say. I'm not going to tell you what the wizard does. Oh, well, actually you have it here, but okay. So you play the game and you figure it out. Okay, and now let's go to the, and let's finish because this is getting way too long. All right, so we have the level drawn and the windows drawn and everything. Now, this is the loop that does the action. This is the action loop. Okay, so for I do. So note that this for loop is a for I do. This means that for I from what to what? Well, it is from 1, which is defaults always to 1, to infinite. Now, obviously infinite is not an option, at least today, in computing. Well, today and never. So what this will do is that it will run until the counter I overflows, and when it overflows, it will continue with the new values, overwrapped values. So what do we do? First we get the module of 7, of the position of 7. So this is a module arithmetic of 7. Why of 7? Okay, so when you do ASCII games, one of the problems that you have is that the movement, when you move something from one position to another position, the movement has to be done character by character. And then that has the obvious effect that it's like a stop motion. It's like it's impossible just by doing that the obvious way, like you have a character and you move it on the screen. It's not continuous, it's not continuous, it's not smooth. The feeling is not smooth because it actually goes like discrete position by discrete position. But back in the day, with Commodore 64, you know, and this sort of system, and disclaimer, I don't know if you see it, but I have my own here, a very common technique was that you actually have glyphs, you have characters that, I mean, you change the character in place before actually switching to the next one. And if you use the right drawing characters, visually it's smooth. Okay, let me show you. So for example, in the ncurses that we had here, we have those ones, which is, we start with the full block, then the left 7/8 block, which is almost full block, then 3/4 block, a little bit less, 5/8, a little bit less, half, a little bit less, 3/8, 1/4, 1/8. Sorry, left 1/4 block and left 1/8 block. So basically you have like blocks like aligned to the left. Okay, this is your left, but you know, diminishing. So, and you have the same for where are they? Here. For lower, on the low. Okay. So this basically means that if you want to move left, right, at the right, this is your right. So what you do is that, okay, you put the foreground color as white and the background color as black. This is relevant for something you will see next. And then you put in the grid, in the viewport grid, you put, in the first iteration, you put the left 1/4 block, which is the small one. It's a very small one. In the next iteration, which is like the next time step, we will see that there is a slip down there. Instead of moving to the next position, you put in the same position, without moving the position in the terminal, you put the other character that is slightly bigger. And the same again, and the same again, and the same again, and the same again, until you reach the full block. Right. Then the next iteration, if you are still moving to the right, then you have to switch to the next character position. and in the next character position, you again put like the quarter in the left. And then again. So this means that in 15 ticks of the clock, you have moved, so 15 time units has passed, and you have changed 15 times, the glyph, the character in two different positions. So physically you have advanced to different positions, but visually you have advanced, in like, it's more smooth because there are like 16 discrete visual steps instead of 2 in the same amount of time. And the same works for up, but instead of using the left 1/4, left 3/8, blah blah, you use the lower 1/8, lower 1/4, 3/8 when you are going up, the same. Okay, now we have a little difficulty here, which is that we don't have, at least in my font, I don't know if the Unicode character exists, exists, maybe yes, but in my font, I don't have right, like full block, right 3/4, right 5/8, and so on. And similarly, I don't have the ones for up. So how do we do that? So the way we do this is by switching the colors, the foreground and background. So if I want to go to the left, okay, which one is your left? There. So if you want to go to the left, you basically use the left field from more field to less field instead of from less field to more field, and you inverse the colors. So here you say turn foreground color is black and turn background color is white, and the same applies if you want to go down. You use the ones from the low, starting with the full block, going to the less full. And yeah, so okay, you may be wondering what is this. So you see how compact Algol 68 is. This is a conditional. This is the brief form of a conditional expression, of a conditional, which is if m equals 0, then all this. And then you, instead of writing if foo, then bar is bad fee, you write if foo, then bar, otherwise bus. Or if there is no else bar, you do like this, right? Which in occasions it's nice, like in this situation. All right, then when you actually move physically when you actually move physically to a different position on the screen, character position, then you do the set visited, because then you say, oh, before I leave, look, before the term left, I mark this, I'm done in this position, but this has been visited. And this is used to detect when the snake collides with itself later. Okay? All right. Then after we move, and perhaps we move to a different position depending on the modular arithmetic here, that would happen every 8 time ticks, or 7th, I don't know. Then we calculate the current position, and we got it like we get it from give me the current position in the viewport for the grid. We get it in cpos. This is the cpos that is used also by setv, remember, lexical scope, and it's very nice. And then we say, if we are out of the grid, I mean, if we moved or we try to get out of the grid, we lose. We lose because the snake crashed. And this is what happens like this. You lose, we lose. And this is done with this, okay? We turn the foreground color to red and the background color to red. You lose and game over. Okay, interesting Algol 68 thing here. What is this game over? Is it a procedure? Well, it looks like that, right? Because it looks like a procedure, looks like the call to a procedure that gets no argument. Well, it's not. It's a label. And it's actually a label that is defined out of this procedure here. So, you see, this is another example. So basically here you have a reference to something that is declared in a range which is accessible, but not this range, is in a range outside, and also afterwards, because there is no definition for this label before, right? So this is equivalent in Algol 68 to this, to go to game over. But you can, if you want, you can omit the goto, which is nice because it looks like the call to a procedure with no arguments. And if you, for some reason, change the definition of game over from a label to a procedure that gets no argument, which by the way they are very related in Algol 68 because a label can be converted implicitly into a procedure that gets no arguments in certain, but I will not talk about this now. You can. Anyway, and if we have reached the cross, the target, the evil cross with the snake, we hit it, it's done. So this is a jump to this done. We exit the loop and we have won the level, right? Okay. And then here we call getChar. getChar is in the POSIX prelude, the POSIX library of Algol, of our Algol 68, of GNU Algol 68. And remember when we set the time? We set the term time to 0. Okay, what that does is, if you don't do that and you do a getChar, getChar uses the standard input, which actually, yeah, probably I should be using the one from the terminal, but it's the same. Okay, this is just a demo. So when you do getChar and you have not set the time to the time to 0, the program will stop and will wait for a character, and then pop, you know, until you do a character, it will stop. But obviously we don't do that. What we want is that, oh, is the user pressing some key? In that case we action, otherwise we continue to the active loop, to the sleep below. And we do that by setting the timeout to 0. So then when the code reaches this, it calls getChar. If you are not pressing, the user is not pressing at this exact moment, actual moment, a key, getChar returns end of file, A of character, A of char. And then, well, here we use to detect if the user is changing the direction of the, pressing some of the direction keys. Now, Algol 68 a specific thing here, which is also nice and interesting. In normal programming languages, when you have an if whatever or while whatever, you have an expression there that returns a boolean or something that can be interpreted as a boolean value, obviously. Okay. In Algol 68, what you have after if and after while, it's something called an inquire clause. What is an inquire clause? Well, an inquire clause is very much like a serial clause, which is like this, like something, semicolon, something, semicolon, I mean something that is to be executed sequentially, but with the difference that labels are not allowed there, and also, so this means you cannot jump into them, and also that they should yield a boolean value. But also, so for example, in this case, this inquire clause is, okay, we declare a constant here in this declaration C, which is a char, which is the value of reading the character. And then if it is L, then this. Else, if it is that, then this. Else, if it is that, then this. Now, note something. Two things. First, the declaration here in this inquire clause is not visible out of the if clause, but it is visible anywhere else inside it, including in the elif parts and the then parts and the else parts. So this is super useful because you don't have to pollute like the environment around in order to have like this, like here something. I mean, this is a very common idiom in Algol 68 and it's very comfortable. It's very nice. It's sweet. It's a sweet thing. And again, this is the programming language with the best syntax ever. Period. Anyway, so if the user is pressing L, those are VI keys, then this means that we want to go right. So if we were already going right, we do nothing. This has no effect. But if we were going left, this also has no effect, because if now I am pressing left, no effect, because you cannot go down. You know, you have to change direction and then, you know, change again. Okay. The same for K, and the same for H and for K. So all the directions. And also, if you press Q, then game over. Then you finish your game. Well, also this is changing the colors and putting the full block here, full block clear, in case you change directions. This is for visually, when you change direction, like to not have like weird half. So you always have a full field character when you change in the corner, so to say. That's how you get, you know, like the nice visual. But this is just implementation details. And that's it. This is the game. I mean, okay, we have not seen, you know, like the draw level one, but there are no like Algol 68 like nice idioms there, or many, or there are, but not that anything I want to talk about. And also it has most of the spoilers of the games, right? So yeah, so this is it. This is all. Of course, this went like super long, but that can't be helped. And if you want to, libterm68 is actually online. You can get the sources. I put them in the repo. Okay, it's not documented here, but I can put it here. It is in HTTPS git source hat libterm68. You can git clone it. You have to install the autoconf and automake that are capable, Algol 68 capable, and this is very important, you need a today GA68 GCC to build this, because again this was written yesterday and I am using this to test the FFI and other features of the compiler that I am fixing like every day today. So if you use it today, then you can play the game and maybe you can reach the wizard and the hell afterwards, and you can see what the wizard does. And that's basically it. Yeah, a nice action little game that is actually fun to play and frustrating in like barely 300 lines of code